Hi, this is Tim Sudol, and this is my demonstration video for Project 9 for embedded software. This is the configuration I have for the quadcopter this week. It's similar to last week, but I moved the batteries to the bottom of the stack to help improve its stability by lowering the center of gravity. As you can see, I moved the power breakout to the side to make it easier to connect to the batteries being on the bottom. And that is pretty much the changes I made to the stack. Next up is the demonstration.
Hi, this is Tim Sudol.
Now getting the Bluetooth to work on the Raspberry Pi and Windows was an exercise in frustration. They kept disconnecting, so the easiest way I found to show that I actually was sending Bluetooth and receiving it was by using the Bluetooth monitor on the Raspberry Pi itself, as well as Wireshark while using the Bluetooth test tools. When this starts up and you see the flight, you'll see packets coming in, and even though it's hard to tell, the payload of the packets themselves do match what the monitor and the MacBook output of the program both say. As you can tell, I recorded this afterwards, so there's a lot of time while waiting for it to start before I start the flight. And here we go. Wireshark is running. Just going through saying there's not a whole lot going on right now until I start the connection. And then over here on the other side, up there on the top left is the monitor. On the RPI itself. Again, the framing on an iPad is terrible. I was hoping that more of that was displayed, but apparently not. So once we start the connection, we could see the monitor is showing some payloads going out, and Wireshark is showing a whole lot of received commands from the remote to the local host over RFCOM. So the Bluetooth monitor is now, if that window was moved over a bit, you would be able to see that the payload on the right matches was coming out of the Bluetooth monitor on the left and what the program itself says it is spitting out. So when I stop the program from sending, we'll scroll up and find that last packet that went out and go ahead and compare the payload from that packet to what is shown on the screen there. And if it worked, the last one that went out should say 2.46, 0.89, 109.35, minus 0.89, 2.46, minus 0.61, and 109.35. Those are the X, Y, Z's, pitch, roll, and compass heading values. Now if we come down here to the Windows machine, if we go up and take a look at the last full packet that was sent, that one right there, it does in fact match that what the screen said the last packet was supposed to be. 0.89. Of course, the framing is off, so it's hard to tell, but the second number is very visible, 0.89, and then the minus 0.89, the 2.46, the minus 0.61, and the 109.35 for the compass heading. And that concludes my demonstration for this project.